And this one, let's take a look at solving this problem. So it says a piece of cardboard measuring 7 inches by 7 inches is formed into an open top box by cutting squares with side length from each corner and folding up the sides. So this is a square. If the horizontal dimension from left to right is 7 inches, for example, and the vertical one, because it's a square, is also equal to 7 inches. So that's also equal to 7 inches, okay? Then besides that, look on the bottom, like if this is x, that's x right there. This is also x. Then when I cut those away, I have 7 minus x, which is 7 minus 2x. That 7 minus 2x represents this portion right here, the middle portion. Let me do that in a different color. You understand what it is. It's this blue portion. That's what the 7 minus 2x represents. Then same thing for the vertical side. Like this portion that I'm tracing in blue, which is that edge, that's also equal to 7 minus 2x. And the reason is the following. Take a look. Again, the whole vertical side is 7 when the cardboard is flat. Then you cut the corners out, which means this x goes away and that x goes away. So you end up with 7 minus x minus x. So that gives you 7 minus 2x. After that, you fold up the sides, and when you do that, you make a box. You do this obviously with a piece of paper. Just cut the corners out and fold up the sides. You will see it is so. So then you can write the volume. Take a look. First, I'm going to put this here. I'm going to put v of x. That's how you read that. V of x equals. First, you put the height of the box. So the height of the box is just equal to x. You imagine, for example, one of these sides, you just fold that up. So whatever x is, it becomes the height of the box. So you need the x in that position. Then after that, you multiply by, for example, what's left over in blue, which is 7 minus 2x. And then after that, you multiply by the other 7 minus 2x. This, if you wanted to think about it in terms of a picture, it's as if you did this. Take a look. When you fold up the sides, I'm going to do a small 3D sketch. It looks like this. Speaking conceptually. You see, you fold up the sides. So now this is x, the vertical dimension. This side right there, that's 7 minus 2x. And then this side on the bottom, that's also 7 minus 2x. When you find the volume of an object like this, you multiply the edges together. That's why it's x times 7 minus 2x times 7 minus 2x. So in this first space right here, where it says find a formula for v of x, you got to enter this whole thing. V of x equals x. So make sure you put the v of x and the equals there, and then it's x, and then 7 minus 2x, or whatever your problem happens to be. The 2x part is pretty much the same. It's the first number, like the 7. That could be a 10 or maybe a 4. That should change. So then you have 7 minus 2x times 7 minus 2x. And make sure you squeeze that in there into the box like that with the v of x and the equals. Then after that, this is the first portion of the problem. Then let's scroll down a little bit and we got to answer some additional questions. Then it says, find a value of x that will maximize the volume of the box. So it says as a hint, graph the function on your calculator or some kind of graphing software and then give the value as a decimal number rounded to 2 places in the first box and the units in the second box. Use IN for inches or IN with a little 3 symbol right here for cubic inches. So first we're going to find the value of x that maximizes the volume. To do that, on the bottom I put a link that says https and then desmos.com calculator right here. Just open that. So right click on it and go to that link. Let this load. And what you want to do is over here type in the specific function that you have. So in our particular case, I'm going to type v of x equals x, and then it was 7 minus 2x, and then another 7 minus 2x, like this, okay? And now this has a picture here, but it's hard to see in the picture what's happening exactly what we need. So you can just use the scroll mouse and then you can zoom out, for example. What you're looking for is the peak. So when I look at the peak, again, the peak right here, take a look. Click right here on the peak and put your mouse over it. You see where it says the following. It says 1.167 and then comma and then 25.407. That peak, the x-coordinate at that peak, the 1.167, that tells you the value of x that makes the volume of the box as big as possible. That number next to it, the y-coordinate, that's the 25.407, that tells you the actual value of the volume. So you need that first, which is the x-coordinate, And then you also need the volume number. You really want to write that point down somewhere for reference with all of those digits after the decimal point. And then do the rounding at the end. So I'm back over here, and what I'm going to do is I'm going to enter the values. First of all, in that first box, I'm going to type in v of x equals, I'm going to put x, that's the height of the box, then I'm going to put 7 minus 2x in my case, and then times another 7 minus 2x. 7 minus 2x. So that's the preview. It looks good. The syntax is okay. That's the way it's supposed to look. In the first box on the bottom now, you see where it says x? That's where you input the x coordinate from that point. Be sure to follow the rounding correctly. It says rounded to 2 places. That means 2 numbers after the decimal point. So in my case, I'm going to input the following. I wrote it down. I'm going to input it now. 1.17. And remember that the x up here, upper right hand corner, the x is what you're cutting out from the corner. I hope you can see that right there. You see? That's x. X is something you could measure with a ruler. Maybe it's like 2 inches or 3 inches. The appropriate units for x are inches, therefore. So in this box, you put IN for inches. For the maximum volume, that's the biggest the box you can be. What you do is you input the y-coordinate from that peak point in the graph. It doesn't matter whether you're using this graphing software online or you calculate it, it's the same step. So here, I'm going to do this. Take a look. I'm going to input the following. I input 25.41 because my actual value from the point was equal to, let me see here, 25.407. But this wants it rounded to 2 decimal numbers after the decimal point. So you got to put 25.41. And for volume, the units are cubed. So for that reason, in this position, you got to put IN, and then this symbol, and then 3. So that stands for inches cubed. So now let's submit this. Take a look. Submit this. And as you can see, all the parts work. So in this first box, v of x, the expression on the right side, this is the x-coordinate from the peak. This is the y-coordinate from the peak. Make sure the units are as included here. And for the volume, the units are inches cubed, just to give you a reminder of that for the following reason. When you have volume, I'm going to do it on the side here. It's as if you had a box. So it looks like this. This is not our specific box. This is just a box to illustrate why the units are inches cubed. Imagine this is 1 inch cube, 1 inch this way along this edge. Imagine this is 2 inches, and then imagine this is 3 inches. To get the volume, you multiply all of the edges together. So in that case, I'm going to have V equals, V's for volume. 1 times 2 times 3, that's going to give us 6. And then inch times inch becomes inch cubed. So that's why over here in this box, you need inches cubed. And that answers all the questions.